All right, this is lesson 10.2, and I'm going to be using our data set from Virtual Academy for the 21-22 school year. So our data set that we have 12 data points, and putting them in order, I have 11, 12, 13, 14, 14, 15, 15, 16, 20, 20, 21, and 28. So when I calculated the mean, I added these all together and I got 199 as my sum. There were 12 data points, and when I divided, we're going to round to the nearest tenth. And my average then was 16.6 for us for our cookie stacking. For the median number, which was in the middle, this turned out to be our 15. For the mode, we actually had three values. So we had 14, 15, and 20, which actually appeared the most often. And then for our range, we would take the highest number, which is 28, and subtract away the 11, which gave us the 17. So I have two other sets of data from my other classes here, and you can see these. I listed them out. You're able to just go ahead, fill in this table with those values. So if you would, go ahead, pause the video and do that real quickly. All right, now that you filled that in, we're going to talk a little bit about comparing these different things and what it can tell us. So if I look at the means, it looks like our class is actually drastically lower in terms of our mean. Our median is a little bit on the lower side. Our modes are typically lower, it looks like, and then our range is actually much greater. So it looks like the other classes had a much smaller range. So what can we conclude about the classes and their data? So basically, it looks like overall, our class was able to stack less Oreos. And I'm able to tell that by using that mean value. It looks like our median number was also a little bit on the lower side too. So generally speaking, just overall, our class was a little bit lower than these other two classes then. It could have been that I asked you for your top two numbers that you had here. So some of you guys kind of had practice rounds maybe at the beginning, and then you got a little bit better for that second round. But it looks like most of these other classes were able to score above 20 with the exception of one group in class two's data. So overall, our class was able to stack less Oreos, and we can see that with our average in particular. We're going to take a look at how do I know which one to use and what affects the measures of central tendency. I'm going to ask you to just pause the video for a second, take a minute and read these three different pieces to this chart. We're just going to be talking about mean, median, and mode for the most part today. So the mean used is our middle of our data set when there's no outlier. So an outlier is down here. So what's an outlier? It's a number that's much larger. So a number much larger or smaller than the others that are in our data set. So when we're looking at our data set, if one of our numbers seems really far off compared to the other ones, that would kind of be a big issue for us, and it would actually affect our mean. So what it can do is if it's much smaller, it's actually going to make your mean a lot lower, and if it's much bigger, it'll make your mean a lot higher. So that is the big thing. A lot of times we do talk about the mean or the average, though, when we're looking at a set of data. For the median, our median gets used to describe the middle of a data set when there is an outlier. So if we have an outlier in our set, the median value is going to be more indicative of what our data set is actually going to look like. It's just not really as popular, which is why we don't often hear about it, but you do hear in the news, like thinking about that, like median house prices, median salaries. And when you look at different towns, like if you look up information online, you'll see information about that. The mode gets used when our data is not numeric or when it's asked to choose the most popular item. Mode is typically a thing if you're having like a vote on something, you're looking at who is going to be the most popular, what outcome is going to be the most popular there. So a lot of times the mode, though, is pretty useless if we're just looking at numerical data because it's just going to tell us which one appears the most. And that's not always the most accurate things that are out there. Taking a look at this first one, this is on page 5. This is discussion point 1. A new building contains 10 rental apartments. The apartments vary in size, and the rental charges are shown in our table. The builder plans to advertise using one statistical measurement that gives a fair representation of the monthly apartment rents. So for our discussion piece here, what I would ask you to look at is just take a look down these monthly rents. And as I'm doing that, I notice that this number does really stick out to me as well as this one because they are drastically higher than the others. Also taking a look too, it looks like there is quite a big range here. I mean, you have $360 up to like $720 a month then. But it seems like most of your apartments are kind of like in this like $500 range for the most part. So that's like 5 of them. That's about half of them. So overall, because there are these outliers, this 1800 and this 3600, the mean wouldn't be good because there are outliers in this data set. So if we had to pick for this one, I would probably go with the median just because it's going to give you the middle value. It's going to be more accurate and more representative of what most of those apartment rentals are actually going to go for. In discussion number 2, Sam was able to list his test scores from the first trimester to see how his math score improved. His teacher made a mistake when grading his one test. The score that's listed as an 84 should really be a 90. So what's going to happen when she makes that change in the grade book? So here's what we have. We're going to cross this off, and now it's going to become a 90. So if I'm looking at this, my range is still going to be the same. So the range will stay the same. It looks like we will have a mode now. So we now have a mode, which we didn't have before. So that's new. Talking about the median, if you actually look at this data set, so if we go from the outside to the inside, our median is actually going to go up because it looks before it was between 82 and 84, and now it's between 82 and 90. So the median will go up. So that's going to go up. And then if we actually talk about the mean, because the score is drastically higher, it's 6 points higher, that's actually going to make that to go up in his grade book too. So his overall score, if she looks at the mean for his grade, would actually go up here. So line plots are a way to organize data along a number line. Each X on the plot represents a piece of data. So we can actually use our class's cookie stacking data to create a line plot, and we're going to not use this sample data set. We're going to actually cross this out here. So we have our data. So we're going to put little X's here. So we do have 1 for 11. We have 1 for 12, 1 for 13. We have 2 for 14. 2 for 15, we have 1 for 16, and then we come up here to 20, and there's 2 of those, a 21, and then also a 28. So which measure of central tendency is easiest to determine from a line plot? So when you visually look at this one, the mode, is going to actually be the easiest because you're going to be able to see which line is tallest here. We can determine the range, so we can look at this top value and we can look at the bottom value. So if we have 28 minus 11, that'll give us 17. And the median height of our cookie stacks. Easiest way to do this is to go from one end to the other, and you're marking these off as you go. And that leaves us with a median score of 15 then for our cookie stacks, which is what we found when we set up our data before. That's it then for lesson 10.2, talking about central tendencies.